Next, we'll talk about records, pages, and files. Concretely, how is our data stored in a database? So records, pages, files. So tables are stored as logical files consisting of multiple pages, each containing a collection of records. So kind of going, from big to small, a file corresponds to one table in this class. And each file will have multiple pages, and each page will have multiple records. Now, the unit of access to physical disk is going to be the page. So one IO corresponds to reading a page from disk or writing a page to disk. We only read in whole pages. So let's start from pages and work our way out. Really, what you need to know about pages is that the page header keeps track of records in the page. The page header may contain fields such as the number of records in the page, a pointer to the next segment of free space in the page, or a bitmap indicating which parts of the page are currently in use. Now, within a page, we can have either fixed length records or variable length records. So fixed length records are when record lengths for a page are fixed and field lengths are consistent. Some examples of fixed length fields are integers, spools, char x, where x is a set length for the string. And there are two strategies to organize fixed length records within a page. The first is called packed records, where there are no gaps between records and the record ID is just a location in the page. So in the packed layout, we need to shift records and keep it packed every time we delete a record to maintain that packed property. Now in the unpacked layout, we do allow gaps between records, but in doing so, we need to use a bitmap to keep track of where those gaps are. So the next time we have an insert, we can quickly identify which gap has free space. They're fixed length records, so we know that there has to be a gap open if the bitmap says so. Okay, next is variable length records. These are either when record lengths are not fixed or field lengths are not consistent. And some examples of variable length fields are text, varchar x, where x is the maximum number of characters for the string. So we can store variable length records with an array of field offsets. And each record will contain a record header. Variable length fields must be placed after the fixed length fields. And the record header will store field offsets, which you can kind of think of as pointers to where the variable length fields end. So this pointer corresponds to the end of Bob or this varchar attribute, and this pointer points to the end of this address attribute, Big Street. Okay, for variable length records, there are again two strategies to organize these variable length records within a page. And both of them follow a general slotted pages format. Instead of a page header, like in the fixed length format, we'll typically use a page footer to allow for the header to grow. So the reason for this is, we don't necessarily know how many records can fit onto a page since each record is variable length. That's why our page header or footer in our case is going to also be variable length. This page footer, we're going to store the length and each record. So each one of these here is, how long is our variable length record and where does it start? So there you can use math to compute, what's the start position, end position, and then a pointer to the next available free space. So that's what this pointer is. Where's the next available free space? And deleting records may cause fragmentation if we used an unpacked layout. So we have packed, unpacked. Unpacked leads to fragmentation since we don't know how large the record will be next. There are various schemes to reorganize records that avoid fragmentation, like on demand. So like anytime we insert and we know that there's free space, but it might be fragmented, we might run some sort of pack the records protocol, which will pack all the records. Okay, next we will move on from the page format to the heap, like to the file implementation. The first way that we can organize pages in a file is with a list, like a linked list. So each page will have 2 pointers, free space and data. So the 2 pointers is like what's the next data page and page. We also have a page, which kind of has 2 sections. The full pages section, which is a linked list where all data pages in that linked list are guaranteed to be full, and a second section, which is pages with free space, where each data page in this linked list is guaranteed to have some free space. There's a second way to implement organize pages in a file, and that's using a page directory. So it's a different approach, and we have instead a linked list of header pages, and each header page is kind of like a grid, which is responsible for a set of data pages. Each cell will store the amount of free space per data page and a pointer to the data page itself. So you can think of like a cell as like a tuple with like the pointer to the data page and how much free space is on that data page. You can also use this heap file page directory implementation for sorted files too. So discussion 4 was on sorting. We can use external sorting to make a sorted page directory. So just kind of connecting some ideas there. And that's it. That's all you'll need to, that's kind of the most important topics for disk files and pages.